Hello and welcome. I'm Ben Widdowson, Marketing Manager at Siemens, and this is the summer 2022 release of Siemens NX. We've got some incredible things to share with you today, so let's get into it. Today, almost every product being created needs to seamlessly blend electronic and mechanical components. From smartphones to smart buildings, ships to heavy equipment, and medical devices to electric vehicles. Every industry is experiencing this explosion of electromechanical complexity, and this creates a huge challenge for the companies and teams bringing these products to market. Here at Siemens, we understand this challenge. We also recognize the huge importance of tight integration across the fields of electronic design, mechanical design, and manufacture. And today, with Accelerator, this integration goes deeper than ever. Bringing these disciplines together on a single platform enables you to build the most comprehensive digital twin, maintain a digital thread throughout the entire life cycle, and collaborate across your supply chain. NX is the industry-leading electromechanical design solution, offering you the most comprehensive design workflows in the most productive modeling environment. Such deep integration and focus on collaboration make this the best release of NX ever. Earlier this year, industry market analyst Lifecycle Insights commented that Siemens NX provides best-in-class electromechanical design tools, smoothly weaving together the different needs of each discipline, all in a tightly integrated, collaborative environment. Our customers across all industries love using NX, like Unlimited Tomorrow, who are on a mission to make custom prosthetic limbs cheaper and easier to access for the millions of amputees worldwide. And Influx, who are under enormous pressure to create mold designs as fast as possible, whilst also making them right first time. And finally, NASA, who seamlessly integrated design, analysis, and simulation, enabling them to meet the thermal challenges posed by the Mars Curiosity rover. Our customers tell us that productivity is a key driver. Electromechanical design teams are under pressure to boost productivity by their executives, whilst also keeping pace with the design and production of increasingly complex, smart and connected products. A staggering 94% of executives are seeking some or a good amount of productivity improvement from their engineering teams. If you want to gain a better understanding of executive expectations and how other engineering organizations are leveraging CAD capabilities to boost their productivity, you can download the full analyst report for free by following the link on screen. With each new release of NX, we're continuing to innovate, pushing the barriers of what product development systems are capable of. Our customers love continuous release, as it gives them access to the latest industry-leading capabilities, enabling them to be more productive and innovate more quickly than ever before. Our customers also tell us that security of their data, people and IP is a top priority, and at Siemens we take security very seriously. Being on the latest release of NX ensures that you're benefiting from the latest security enhancements. NX helps you collaborate more easily, increase productivity, and embrace electromechanical complexity, all in a secure environment. Today, we're going to share an end-to-end workflow covering electromechanical design, mold design and analysis through to manufacture. Let's head into the office and jump into the demo. So, as we head through to join the design team, the design manager has tasked the team with increasing the processing power of the onboard infotainment system. The electronics team will be working to add additional chips and a new heat sink to handle the increased processing power, and the mechanical team will have to redesign the housing to encompass those new electronics. So, let's hand over to Dave for the first part of the demo.
So we're looking at the active workspace environment embedded in the NX session, and I have a new notification in my inbox. I see I have a new change request that I need to act upon. Let's open that up and we see that it's regarding the infotainment upgrade. Looking at a bit more detail tells me the infotainment system needs to be enhanced to provide the latest capability in entertainment, navigation and device connectivity. Memory traces will need to be improved and increased processing power will be required. And that will require a heatsink to be added, and that in turn may require changes to the housing to accommodate it. The items affected are listed and can be opened directly into NX. As we explore the impacted items, selection in Active Workspace highlights them in the NX for easy identification as we get familiar with the change. We'll open the main assembly that shows the current infotainment housing, and finally we'll open the detailed assembly and reveal the PCB that will be modified. Now we have a clear understanding of the parts that will be changed to support this upgrade and can progress with the change request. The first change is to convert the PCB from rigid to rigid flex. We edit the layer scheme to be a rigid flex construction and create the features for the second rigid segment and create the flex segment, both at the appropriate board thickness. Finally, adding stress relief where the flex enters the rigid segment, then developing the board to the flat state. Once the board changes are complete, we move the connector to its new position and are ready to publish the changes for the board and the connector to the electronics domain. The published data shows the board geometry and thickness change. Now in Expedition, the electronics designer receives the change and reads in the collaboration data of the board and the connector modifications. Both domains are now synchronized. The new functionality is now added to the board and the change is prepared for sharing with the mechanical team as a proposal of change. During the time I review the new component placement in NX, trace routing can be continued in different partitions of the design. As requested in the change note, the DDR memory chips are rerouted. They allow very high transfer rates, which requires extremely accurate timing between the different electrical and clock signals. So here they define a sketch path to automatically route a group of net lines to follow the same pattern while meeting the signal integrity constraints. The design change has now been reviewed and the final board has been completed by adding the heatsink and the flex, folded, ready for integrating the design into the overall assembly. The final design is then validated using a common rule set shared between both tools, giving the confidence that the mechanical and the electronic domains are in sync and saved to Teamcenter. The design is valid, and in the next step, we'll head over to the mechanical design team.
So Dave's given me the updated PCB for the infotainment system. So we're going to take a look at it and see if there are any issues. I've got the assembly opened in NX and I'm just going to isolate the infotainment system. Just going to remove some of the outer casing and we'll remove the back cover. And you can see the original board in the back of the infotainment system. So I'm going to replace that with Dave's new PCB. You can see that. And we'll include it now in the assembly. And then we can take a look and see if there's any issues. So you can see there's the new assembly. It's got the heatsink in it. And when I bring back the back cover, you can see it's actually protruding. If we can take a slightly better look at that by clipping it, you can see through the section of the model where the issue is. So I'm going to need to make a modification to the back cover. And it'll also give me the ability to add a little bit more of an organic shape to this, a little bit more aesthetically pleasing. So let's take a look how we do that. We'll make the back cover our working part, and you can see we've got a fully featured model. And I'm going to roll back the feature tree to a position where I can make my changes and then roll the model forward to incorporate those changes. So I'll roll it back and we can start to construct a shape which is going to alleviate the issue that we got with the heatsink protruding. So I'm just going to use some synchronous modeling first of all to remove some of the blends. As you can see here, very easy to do that. And let's just extrude this back face. And I wanted to obviously go past the heatsink, but what I'm going to do is to ask it to be offset from the back of the heatsink. by 4 millimeters. So as you can see, I've got some decent clearance now. Once I've got that, let's add a little bit more shape to it. So we're going to add some draft. So again, we can pick up on add some draft, pick up on that face as the direction, and we need a stationary face, which should be the back face of this part. And then we can select the faces that we want to draft. And we'll add some draft to 2 of the other faces. We'll change the value this time, which will be this one here, that face, that one there, that one there. Okay, so I've got the base shape. So I'm just going to divide this back face here between that point and that point. And again, using synchronous technology, we're just going to move this face down a little bit. That's fine. So let's just unite that face with that new model. Okay, and we're going to add some shape. And to do this, we're going to use X-Form. X-Form gives me the ability to select a face, give me options to make it easier for me to add some form. So in this case here, I'm just going to drag that face out using the control polygon. We'll apply that there. We can pick up another couple of faces. This one at the top. Again, we can add some form to that. And I can continue to do that with some of the other faces on the model to get the shape I need. So as you can see, we've added a few more features to our model, a few more blends. I've just got one more blend to add, and it's going to be on this set of edges here. So again, we'll just drag it to size, and we'll okay that. So there we have the one half of our model, and you can see now that we've removed the collision between the heatsink and the back cover. We've given it a little bit more form, make it more aesthetically pleasing. All I need to do now is to roll the model forward to the end of the feature tree, and all of the features will replay, taking into consideration the additional features I added to the model. And there you can see it's completed. What we can do now is unclip, and there is our completed modified back cover. I'm going to head over to see Sam to see how we can collaborate on the detail design. I finished that design modification on the rear cover, and I thought we'd take a look at it and see what else needs to be done.
Excellent. So let's get started working on this so we can get this project done. As we collaborate and review the electromechanical design of the infotainment system, we have been notified that the PCB design has been upgraded to accommodate a larger heatsink. This design change will require us to make additional venting slots to the back cover to meet this heat transfer requirement. As we had a chance to review this design's history of the back cover of the display housing, we see that if we insert the venting slot at the earlier part of the design intelligence, we can minimize the workload and maximize the efficiency. We'll now insert a couple of these feature templates for the venting slots to our rear housing cover. These templates require some input parameters, then it will automatically embed intelligence venting slots along with the proper PMI entities onto the cover. Reuse features and feature templates are all part of NX standard functionalities that can provide companies IP into their design process. Many of these plastic injection features are a part of the standard design. We have enabled and reused these intelligent features that can quickly complete the task at hand and then focus on other time-sensitive items. Once these features templates are added to the housing cover, users can see how NX is maintaining that intelligent design within its history. From the feature history, I have already created several standard plastic injection mold features. I will quickly show you how they can be quickly added to the current design. Adding timestamp and RIC as simply as drag and drop these intelligent features from the reuse library onto the target placement CSys. As you can see, that usage of reuse library is comparison to the designer that had to create these features manually demonstrate the power of NX in a design process. To increase the productivity of the plastic injection manufacturing design, usage of reuse of these standard features will support that requirement. Now we have completed these design tasks. We see that NX is tracking that these design intelligent features for any future design change. We'll now take a quick look at the infotainment system. By removing the rear cover, we see that quickly we were able to add these cooling slots to support design change and collaborate with others in the engineering process by using Siemens NX. I have now completed the design change. We'll hand it back to Paul.
Thanks, Sam. I can see I have a notification showing that changes have been made to the assembly. I can now reintegrate Sam's changes back into the master model. Well, you can see that the new electronics are now housed correctly in the enclosure. So we're ready to hand over to Matt, who's going to run a thermal validation before we get the part manufactured.
Thanks, Paul. We're going to use SimCenter FlowEFD for NX to perform 2 thermal simulations to see how the 2 rear cover designs, with and without cooling holes, impact the temperature of the electronics inside. We're now in FlowEFD. Using a template, we've created a project to simulate the back cover without holes first. All the correct material properties have already been assigned. The materials specified in the NX model can be used, or new ones specified as desired. The mechanical representation of the PCB and components is replaced with a thermal representation that includes all the necessary material and thermal attributes for fast and accurate simulation. In this example, FlowEFD's Smart PCB technology is used to enable the detailed copper distribution in the PCB to be modelled without significant computational overhead. A detailed component model of the microprocessor is also used. This level of detail in the PCB and component models is key to obtaining accurate predictions of component temperatures. Before we run the first simulation, let's clone the project to create a second simulation featuring the modified cover with additional cooling holes. Now we can solve both projects. Both simulations have finished and we're ready to review the results. Straight away, we can see just from the summary results shown in the 2 solver windows that the addition of cooling holes to the rear cover has had a significant impact on the junction temperature of the microprocessor. Inspecting the detailed results of the second simulation with cooling holes, we can again see the junction temperature of the microprocessor is about 105 degrees C. We could review the results of the first simulation without cooling holes in exactly the same way, or use FlowEFD's built-in compare tool to compare both result sets side by side. From this, we can see that the addition of cooling holes has reduced the junction temperature of the microprocessor by about 7 degrees C. A temperature reduction such as this could prove significant in ensuring the long-term reliability of the product. Now the thermal simulations have been completed, I'm going to hand over to Boris, who will collaborate with our supplier on manufacturing.
Thanks, Matt. Now that the plastic housing has been revised and completed by the mechanical engineer, I can use NX Mold Connect. NX Mold Connect is a new Siemens cloud-native SaaS solution that connects OEMs with their trusted suppliers to efficiently manage collaboration. It's used to ensure that parts are fit for manufacture, to speed up the design cycle by eliminating rework and extra cost. With instant-on access, there is no deployment or configuration necessary, so getting started is quick and easy. After logging into NX Mold Connect using my internet browser, I can start by creating a project for the infotainment system and set the project number and due date. Then I can upload the display housing plastic part along with the part spec. After the upload is completed, I can create a quote request. I'll see that the status displays that this is a new request, which I can add files to. After the request is created, I can add files to it from the project. Next, I add my trusted suppliers to the list of suppliers in the RFQ. I can choose from several file access permission levels and send the request. I can see that the status of the quotation is updated to out for quote, and it also shows that the quote has been sent to both suppliers. At this point, I'll wait to hear back from the suppliers.
Thanks, Boris. So I've just received an email letting me know that I have a request for quotation from my customer. Let's check it out in NX Mold Connect. Using Mold Connect makes it easier for me to collaborate with my customers on mold quotations. I'll start by creating a quotation based on the part and spec provided by the customer. The status has now changed to acknowledged, so they'll know that the RFQ is in review. The first thing I'll do is open the part to run design for manufacturing analysis. I can see that I have a choice to perform a few different types of analysis: geometry, wall thickness, and mold fill. In this case, I'll start by selecting the body, the draw direction, and setting the draft angle limit. Once the calculation is completed, I can see several different types of results. The draft analysis shows the regions with different ranges of draft angles. I can show and hide the regions to inspect the model and find problem areas. After hiding the drafted regions, I can see that the sides of some of the holes have not been drafted, so I'll capture the feedback and send it back to the customer. From the analysis, I can see that the model doesn't contain any undercuts that require additional sliders, keeping the cost of the tool down. Cavity and core regions are well defined, so I'm going to send the report to the customer showing that the parting line, wall thickness, and mold fill results are acceptable for manufacturing. We're back, and the customer has now corrected the draft issues, so I'm now ready to generate a cost estimate by using results from automatic feature recognition. This makes creating a quote quick and easy, and I can share it directly with the customer in NX Mold Connect. So let's go ahead and send it. We've received the accepted quote back from the customer, and we've been awarded the job. So let's go ahead and jump into NX to design the mold base. To design the mold base, we're going to use NX Mold Wizard. NX Mold Wizard embeds tooling expertise into NX, enabling you to create molds based on the product model with full associativity between the two. NX Mold Wizard helps you decide the mold direction automatically based on the part geometry. We're going to use an existing reconfigured project, then select the materials of the part to initialize the mold design activities. As you can see, workpiece has been added automatically. This layout will be multi-cavity. In this case, we'll choose the rectangular option, followed by the number of cavities and the distance between them. Embedded mold filling simulation inside NX can simulate the entire filling process of injection molding. It's an important step to understand where problems may occur in the cavity filling phase, so we can further optimize the design. We're going to take the cavity layout previously created and analyze it. Using the layout, we can define the process conditions for validation, and NX Easy Fill Analysis provides 6,000 plus commercial materials out of the box. We'll select the material, producer, and grade for the part. Next, we'll define realistic runner and gates for the mold design and define the mold direction. We can then go ahead and set up the processing conditions. NX provides capabilities to simulate the filling and packing or entire filling, including packing, cooling, and warpage. For this mold, we'll go with a full analysis. Next, we want to set the process condition such as injection pressure and filling time, and then let it run for solving. Once it is solved, we can visualize the results. We'll start with melt front time to see how long it takes to fill the cavity, then move on to weld lines, air trap, gate distribution, pressure, and finally, we'll take a look at warpage and packing. Once we understand what's going on with the injection process, we can automatically prepare a report to provide feedback to either designers or customers to see if there are any adjustments that need to be made either on the part, mold design, or injection process. In this next stage, we'll identify the core and cavity regions, creating parting surfaces and extract the core cavity. With the use of check regions on the check regions function, we're able to easily identify core and cavity regions and assign colors to these, which will later be used for creating parting lines and extracting regions. NX Mold Wizard has advanced automated tools for creating optimal parting lines based on the draw directions and different regions defined. NX identifies the openings on a design part and automatically creates shut-off surfaces needed prior to extracting the core and cavity. NX Mold Wizard guides you through the creation of parting surfaces with recommended surface types based on the geometry conditions. With the parting surfaces defined, a single click is all that's needed to automatically execute the core cavity extractions. Finally, these files are added to the top level project. This shows the power of NX Mold Wizard, improving your productivity by automatically managing the appropriate project structure. Now we're in the position to create the 3D mold base using a library built on industry standards such as Hasco and DME. NX Mold Wizard provides a large number of standard model parts out of the box, covering many common vendor components. You can also configure your own standard parts. Go ahead and choose a mold base from the reuse library. You can select the desired index and adjust the parameters to create the 3D mold assembly. NX provides a visual preview of the mold base too. Once the mold base is created, it's added to the mold structure automatically, and you can see the moving and fixed half in the assembly navigator. Improving the part time and quality is important, so you're going to add conformal cooling channels to both the core and cavity inserts to achieve this. Mold inserts with conformal cooling channels can be easily created using additive manufacturing processes, which we will see later on. NX has various ways to create a conformal cooling channel, but in this instance, we'll use the projection method. There is a sketch profile that will be projected onto the product surfaces in the mold cavity. The first task is to define the minimum distance that needs to be maintained between the product surfaces and cooling channel center. We can then choose the bend radius to achieve the proper flow of cooling water, and finally select the sketch mentioned earlier. And there you can see the cooling channels with the desired conditions have been created. All that's needed now is to complete the design by creating inlet and outlet of the cooling channels, then the injection systems based on the mold filling simulation we performed earlier. Now that the mold design is complete, I'm going to hand over to Joe on our manufacturing team, who'll be 3D printing and finishing the mold.
So we received the design part now from Jamie, and we're ready to take it into the NX Additive Manufacturing environment to prepare it for printing on the Renishaw printer. So we can see from the geometry that's been designed by Jamie that this is perfectly suited for additive manufacturing. We've got lots of internal cooling channels which wouldn't be able to be produced in any other way than additive manufacturing. So let's take the part into the NX AM environment. So we create a new NX session. The first thing we're going to get asked is what printer do we want it to go onto. So I've got a representation of the Renishaw print tray already configured in the AM environment, and that gives us an exact representation of what's like in the Renishaw printer behind me. We can now move on to positioning the part. So it's really important that the part is positioned in such a way that it reduces the amount of support materials, because that's time consuming to remove. Also make sure we have the highest quality component that can be printed. So if the part was a little more complex or not as prismatic, we could run some orientation optimization, which will give us that best orientation. But in this case, it's pretty simple. We're just going to flip the part 180 degrees round. And then what we're going to do is move it 5mm off the printer bed so that it can be removed easily. So the next stage will be to apply some support materials. There's two ways we can do this. We can either use the automatic support creation, where NX will look at all the geometry and analyze any areas that will require supports, and it will apply them. The second way to create supports is to simply select the part and then select the faces you want to create supports on. So I'm going to select the part, select the lower face. You'll notice there was an area called support profiles. Support profiles is where we can store and retain different types of supports, different parameters for those supports that can be used or specifically dialed in for particular materials, for particular printers and for particular geometries. And that really makes it easy for a business to standardize on what support profiles work best for their components. As we can see here, we've got the generated block supports and everything looks really nice. And the next step we need to do is prepare that particular part for the printer. And to do that, we need to assign a build strategy. So in the build strategy, we've got some parameters such as the layer thickness, and the laser patterns that are going to be required. And again, that can be material specific or it can be printer specific. But regardless, we can set them directly in NX, and we can simply hit the generate button and start the slicing. What happens then is NX, it will break that geometry down into all those slices so that there is an output file ready to go directly into the Renishaw printer behind us. Just before we do send that part out, we can take a quick preview of what that looks like in the path viewer. And by dragging this handle across, you can see all those different layers that have been sliced, all those internal cooling channels, how it's going to be printed out, all the way down to the support materials at the bottom. Okay, and that's about it. We're ready to take the output file from NX directly into the Renishaw printer behind us and start that print. I'm now going to head over to the machine shop for the next stage. So here we are on the shop floor, but our additively manufactured mould, and we're going to do the final machining of the finished mould here. So we have the finished component here in NX, and we also have the part as it came off the 3D printer. And we left extra material on the 3D printed part so that we could finish machine those faces to ensure a high surface quality for the injection moulding. It's really simple in NX to be able to create machining operations to finish machine this component, and that's what I'll take you through now. So here we can see both components overlaid, and you can see the extra material between the finished component and the part as it came off from the additive manufacture process. And you can see it set up here in the machine tool station. The first operation is quite a simple one. We simply want to remove that extra level of material using a floor facing operation, and I can quickly replay that for you now so you can see the material being removed. Once that material has been removed, we can start working on the surface machining operations. The next set of operations are for the injection moulded surfaces, so they need to be of a higher quality and of a higher surface finish. For that, I've created an area mill, and because it's quite complex and quite a large surface area, I'm using a larger ball tool to remove the bulk of the material as quickly as possible. We've still got a lot of material to remove because of the size of the radius against the surfaces in the mould. So in NX CAM, it's really easy to copy and paste that operation, simply drag it under a smaller tool and ask the operation to only remove the material that's left from the previous operation, the rest material. And that's what I've done here. When I click play on the operation, we can see the machine tool moving around with the ball nose, removing those last few bits of material. Unfortunately, because of the complexity of this mould, there's still some small corners of material that need to be removed. For those areas, I'm going to use the new flow mill operation. The new flow milling operation is perfect for removing these areas of material, creating high quality smooth tool paths. But the biggest problem here is we need to use an even smaller tool, and a smaller tool can only stick out so far. So what you can see here is the tool cannot go all the way down. It can't finish the very bottom areas of the mould, and that's because there will be a collision. There'll be a collision between the tool and between the holder. And that's where the intelligence of NX has trimmed the tool path. So we've got a completely safe tool path, but unfortunately we haven't been able to complete the machining operation. But that's not a problem. I'll show you a really clever trick in NX. And what we do is simply turn off the collision check-in. As a user, I can make that decision to turn off the collision check-in, and that's going to give us a full smooth tool path. But as you can see here, we now have a collision between the tool and the tool holder. But that's where the really clever stuff comes in. And with a couple of clicks, I can go to the tool path and I can activate what's called tilt tool axis. And what NX is going to do now, it's going to look at all the areas of collision between the tool, the holder, and the component we want to machine, and it's going to tilt that ball nose away. So we're taking a high quality surface machining operation that was traditionally for a 3-axis setup, and now make it fully 5-axis simultaneous. Once that's generated, we'll be able to verify the toolpath using our integrated NC-driven simulation and see the actual robot moving around, creating this full 5-axis toolpath. So here we can see we've got a completely collision-free, fully 5-axis toolpath. And if I just zoom out slightly for the toolpath replay, here we can see the robot driving the tool around the mould. So now the mould's finished, we can get the housing injection moulded and sent back to the customer.
Thanks, Joe. So we're back at the design office and we've received the redesigned infotainment housing. We've also received the all-new upgraded PCB back from our supplier. And as you can see, the team has assembled the complete redesigned infotainment system back onto the vehicle. So we've covered a lot of ground today. We showcased the power of NX's integrated environment for electromechanical design. You also saw how OEMs and suppliers can collaborate seamlessly across the mold design, procurement and manufacturing process. If you're an existing NX customer, you can learn all about the latest capabilities, tips and tricks directly in NX. Simply open up Discovery Center to explore and try out the latest features. And if you're not yet an NX customer or you're just curious, you can try NX free for 30 days using our cloud-connected trials. Go to trials.sw.siemens.com/NX or scan the QR code on screen to take a look. And finally, whether you're an experienced NX user or learning NX for the first time, I'd encourage you to check out the NX design community. Head over to community.sw.siemens.com where you'll find other like-minded NX users ready to help you. And of course, the NX team is always available to answer questions should you need us. Thanks for joining us today for the launch of NX Summer 2022. As always, we'll be hanging out in the live chat, so please keep posting your questions to the team. Thanks again for watching, and we'll see you in the next one.